Although the term black hole wasn't actually coined until 1967, the concept itself actually dates back centuries earlier. In 1784, English cleric John Mitchell was the first to propose the idea that mass could be compressed into such a tight ball that its gravity would cause light to fall back onto itself. A similar description of a black star so massive that it captured its own light was conceived by the French mathematician Pierre-Simon de Laplace in 1798. But it took one of the greatest scientific minds in history to accurately predict how these objects would work. Albert Einstein challenged the fundamental assumptions about the absolute nature of space and time. No longer were space and time seen as independent absolutes, but as different facets of a single continuum. He called this continuum space-time. In 1916, Einstein presented to the world his general theory of relativity. In general relativity, the space and structure of four-dimensional space-time is curved and twisted by the presence of matter and energy. In Einstein's universe, gravity is no longer a force that attracts matter. It's the curve and warp of space-time itself. Because it is difficult to imagine curving space even in 3 dimensions, let us use a 2-dimensional analogy. In 2 dimensions, the presence of the sun warps the fabric of space-time in a manner similar to a bowling ball warping a spandex sheet. The sun, like the bowling ball, creates a dip in the fabric of space-time. Therefore, according to Einstein's theory, light will actually bend or dip as it passes close to the sun. But the general theory of relativity, as brilliant and detailed as it was, still lacked one thing: proof. To support it, scientists would actually need to prove that the sun bent light. And in the early years of the 20th century, the only way to do that was during a total eclipse of the sun. The year is 1919. A total solar eclipse is imminent. One British team travels to South America, another to Africa. Their goal? To perform the first true test of the theory of general relativity. As the bright sun is hidden by the moon, stars near the sun are photographed. On comparing these pictures to previous photographs of the same stars taken at night, the stars are undeniably out of place. The sun is indeed bending starlight. General relativity has been proven. In the extreme high-gravity environments that reside